Hello. In this video, we will cover section 3.3, which is on the median and interquartile range. In the section on the mean, we noted that for a skewed distribution, the center as the balancing point did not produce a result that made sense as the typical value. The mean is off-center in such cases. For example, in the image below, the mean is greater than 65% of the observations. So you can see right here, this is where the mean is. Meanwhile, this bar here to the left of it contains 65% of the observations. So that doesn't really make much sense for the typical value to be that far along in the distribution. Another way of measuring the center is as the middle of the data. This is called the median. This is the value that would be in the middle if the data were sorted from smallest to largest. Half of the observations are above the point and half of the observations are below. Below is an example of a distribution with the median placed in the middle of the data set when ordered from smallest to largest. With 10 observations, the median is halfway between the fifth and sixth observation. So in this case, this is a data set that contains percentages of fat in ham. And so you can see it's a dot plot. We have 10 total dots, and the median is placed in the middle of the data set. Since there are 10 dots, it's going to be between the fifth and sixth, all right, observation. Okay. All right. If we go ahead and apply the median to the distribution from the first slide, it visually makes more sense for the center. All right, so we can see here, there's the median. All right, it has to be in the middle of that really big, tall bar that contains 65% of the data. And so from there, it makes more sense to have the typical value somewhere in that bar, since that bar contains so much of the data in the data set. To calculate the value of the median, first sort the data from smallest to largest. Then, if the data set contains an odd number of observed values, the median is the middle value. If the set contains an even number of observed values, the median is the average of the two middle values. This places the median precisely halfway between the two middle values. Let's look at an example. So we want to find the median price of a gallon of regular gas at 12 Austin, Texas gas stations. So we can see here, there's the distribution. So step one, we want to sort the data from smallest to largest. Well, that's done. And then we need to count up how many observations there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since there are an even number of observations, the median is going to be the average of the middle two. So if the middle two, so you want to go ahead and find the middle two. To find the middle two, what you can do is you can take the number of observations and divide by 2, and that's going to give you the first one, right? So if we've got 12 and you divide by 2, then the first half of the middle is going to be the 6. So we want to go 1, 2, 3, 4, 5, 6. That's the first half, and then 7th is the second half. And so you just take those two and average them, and that gets you the median. All right, let's do another example. So we want to find the median percentage of fat from the various brands of sliced ham for sale at a grocery store. So there they are. So first, we need to sort the data from smallest to largest. So we then count up how many we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so when you have an odd number, the median is just going to be the middle one. And to figure out which one that is, what you can do is you can add 1 and then divide by 2. So since there were 11 observations, if you add 1, that gets you to 12. And then if you take the 12 and divide by 2, that gets you 6. So it's going to be the 6th observation. So you just do 1, 2, 3, 4, 5, 6, and that's the 1. Okay, so that's how you can handle odd numbers of observations when it comes to calculating the median. All right, let's jump to the second part of this lecture, which is on interquartile range. The variability equivalent for the median is the interquartile range. The interquartile range tells us how much space the middle 50% of the data occupies. It is the distance between the first quartile of the data and the third quartile of the data. So in the example below, it would be 40. Okay, so the idea here is that you go through, you've got the data, you want to find where the 25th percentile is. Okay, that's the first quartile. And the 75th percentile, that's the third quartile, and then you just subtract the two. So you take 160, third quartile, 120, first quartile, and then so the middle 50% takes up 40 points worth of space. And so that's how we can go through and get a measure of variability when it comes, that's consistent with our idea of the median. The interquartile range is most easily interpreted through comparisons between distributions. Distributions below contain the weights of students split by gender. The interquartile range for the men is 38, while for the women it is 20. And then thus we can say that the men have more range or more variability. All right, so the bottom distribution has the men, the top distribution has the women, and you can visually see that the range, so here we have the median, this is the first quartile, this is the third quartile, so we can see from the first to the third quartile, that gives us some idea of variability. That's the middle 50% takes up that much space. And then we can see the women, here's the median, here's the first quartile, here's the third quartile, and we can see how much space that one takes up. And you can see that the male one is bigger than the female one. And so there's more variability. There's a wider spread in male weights than there is in female weights, at least in this data set. All right, so to find the interquartile range, first you want to find the median of the data set. This is the halfway point, or the second quartile. The median cuts the data into two groups. Once you've gone ahead and found the median and you've split the data into two groups, first you want to find the median of the lower half, the first group. You want to find the median of the lower half of the sorted data. This is the first quartile. And then you want to find the median of the upper half, the second group. And then this is going to be the third quartile, and then you just subtract the two of them. All right, so let's do that, because that may be a little bit confusing. So let's say we've got a data set. The data set is the heights of 8 children listed here. You can see there are numbers, they're there in the pictures. All right, so first things first, we want to find the median. So we want to go ahead and find the median of the data set. So to do that, we count up how many well, first we sort the observations, so we can see they're already sorted. Next, we need to count up how many there are. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8. And so we have an even number. So that means we're going to be averaging the middle 2 to figure out what the middle 2 are. Take 8, divide by 2, and that gets you 4. So 4 is going to be the first half of our middle 2. So we go 1, 2, 3, 4. That's the first half. And then 5 is going to be the second half. And so that's our middle 2. Take those, average them, and that gets you the median of the total data set. And so there it is written out. So you've got the first 4 kids, the second 4 kids, and then the median or the second quartile right between them. All right, so next we want to go through and find the median of the first half or the first quartile. So the way it works is that when you're going through and you're finding the interquartile range, you first split the data set into 2 groups. All right, and that's by finding the median. And then once you've done that, you're then going to find the median for each of the subgroups. Okay, and so that's what we're doing next is we're going to find the median for these 4 here, and that's going to give us the first of the interquartile ranges. So to find the median for these 4, first you've got to make sure they're ordered, and they are. And then next you need to count up how many there are. 1, 2, 3, 4. Now that's an even number. And so that means we're going to be averaging the middle 2. And you can kind of see this what the middle 2 is here, but you could take that trick I've mentioned a couple of times, 4 divided by 2. So the second and third observations are going to be the middle 2 here. So you want to take 48 and 53, and you can see that's written there. Average them, and that gets us the first quartile. And there's the first group with the quartile right in the middle, because it's the first quartile is the median of the first group. And then we go through and do the exact same thing for the second group. All right, so the second group is here, and it goes from 54 to 71. We then want to go through and find the median for that group. And again, it's got 4 observations. That means we're going to be averaging the middle 2. So the middle 2 are going to be 60 and 62. Go ahead and average them. You get 61, and that's the median for that group. All right. So then at this point, we have the quartile results. The first quartile is the median for the bottom half. The second quartile is the median for the entire distribution. And then the third quartile is the median for the top half. And then the interquartile range, we take the third quartile and the first quartile and we subtract them. So the interquartile range is 10.5 inches. And then you can see the data set here with all of the kids as represented as dots for a dot plot. And so there's the median, and then we have our quartiles. Let's look at a homework example. So let's say we've got the top 7 movies based on DC comic book characters for the US box office as of fall 2017 are in the table. So these are box office results for a bunch of DC movies. They want us to go through and find and interpret the median, find and interpret the interquartile range. So you'll see IQR frequently for interquartile range. I haven't mentioned that yet. They want you to find the range of the data, which we haven't mentioned the range at all. I'll explain what the range is when we get to that part. And then explain why the interquartile range is a better measure of variability than the range alone. Okay, so first, find and interpret the median. All right, so we've got our data set here. We want to make, if we're going to find the median, first you've got to make sure that it's ordered, and it is from bottom to top. And then you need to count up how many observations there are. 1, 2, 3, 4, 5, 6, 7. So there's an odd number. That means there's just going to be one median, and that's going to be the middle observation. To figure out what that, you can kind of see what it is just by looking at it. But the trick that I mentioned earlier is if you take the number of observations, there are 7. You add 1, you'll get to 8, and then divide by 2 to get to 4. So that's the 4th observation is going to be the middle one. So if you go 1, 2, 3, 4, it's 487. All right, so the middle observation is the 4th observation, which is the dark night rises at 487. So that's our median. Oh, and then the interpretation is half of the observations make more and half of the observations make less than the median. Find and interpret the interquartile range. All right, so if you're finding the interquartile range, the median splits the distribution in 2, and you want to find the median for each of the subgroups. So we've got a subgroup here, the bottom half, we've got a subgroup here, the top half, and you want to find the median for each. And with 3 observations, that has an odd number, and the median is going to be the middle one. So the median of the bottom half is going to be 366. And then again, we've got 3 observations. The median is the middle one. And so that's going to be 547. And so then we take 547 and subtract 366, and that gets us the interquartile range. And then the interpretation of that result is that the middle 50% had a $181 million range. All right, so find the range itself. So what is without the interquartile part, so what is just the range? So the range for a distribution is the largest value minus the smallest value. So we would take the largest value, which is 643. We take the smallest value, which is 346, and we subtract them to get 297. So the range is 297 million. That's largest value minus smallest value. And then the last part, explain why the interquartile range does a better job measuring the variability than the range does. The problem with the range is that it's dependent upon only 2 values, the largest value and the smallest value. So you can make a huge change in the range just by changing, or adding another value that it increases the largest value or decreases the smallest value. So that makes the range very unreliable, because you can make such a large change to it by just going through and making one relatively minor change to a distribution, right? You could have 100 elements in your distribution, 100 observations, and you could go through and you could measure the range, and you could have one range, and then you could add one more observation, 101st observation. And if you went through and it was significantly larger than the largest value or significantly smaller than the smallest value, then suddenly you get a completely different range by adding one value to a relatively decent sized distribution that has 100 observations in it. Okay, and so that's not very reliable. it's not going to be very dependable, right? So meanwhile, the interquartile range is a location within an ordered data set. So if you go through and you order your data, and then you go through and use locations that are somewhere within the data set to measure the variability, then if you just add one more observation, it's not going to change the it's not going to change the ordering, right? The most it can do is maybe shift the interquartile range by like one observation. So it might move it over one observation, but typically the observations are relatively close together, especially in a large distribution. And so because of that, you'll find that the median is very sticky. The median doesn't change much if you go through and make, one change, certainly one change, but you can actually make a significant number of changes to a distribution, and it won't make much difference unless those changes are close to the median, okay, or unless those changes move observations from below the median to above the median. That would actually cause the median to shift. But you could go through and you can make all changes all throughout. If you had 100 observations and the median is the 50th one, then you could go through and you could make changes to the 70th observation and the 71st and the 72nd. So again, I'm assuming they're ordered here. You make 70th, 71st, 72nd. You can make huge changes to those, and it's not going to make any difference to the median because the median is just right there in the middle. It's the 50th and 51st. So that's the benefit of the median is it's extremely sticky. It's very difficult to move. And so my personal opinion is I love the median. So the median is my favorite measure of center. I actually like the median significantly more than the mean because it is so sticky. And so anytime I'm going through and I'm doing data analysis, I almost always break out the median. So again, I'm not doing a slide on this, just kind of making some comments. But the reason you do the mean is the balancing point, and that works on symmetric distributions really well, whereas the median works great on skewed distributions. Well, the median also works great on symmetric distributions, actually. If you think about it, like why would the median suddenly do a crappy job with symmetric distribution? It also works great. So the median works great on both symmetric and on skewed distributions, whereas the mean is much more limited. It only works well on symmetric distributions. And so you might ask yourself, well, why would you use the mean then if the median is just better? The main reason you'd use the mean is the empirical rule. It's all that stuff with, being able to go through and say if there's within a standard deviation, then you can go through and have some estimate of how much of the distribution is going to fall within a range. So it really comes down to going through in the standard deviation. If you're not actually doing standard deviations, if you're not doing anything with that, then I think the median is just a purely superior measure of center. But anyway, that's my opinion, maybe not shared by the statistics community at large, but it is what it is. So anyway, I think I answered this homework question. The range is not a good measure of variability because it's dependent upon only two values in the distribution. Okay, that is the video. That's it. Thank you for watching, and I'll see you next time.